very good example of a final evaluation question you guys might see in the TAS course. It's based on you having all these formulas that we've already discussed. You'll be given these as well as the efficiency formula, and you all have been handed out this sheet, which is two-sided, with all the mass, weight, and gravity calculations and everything else on it. That is yours to use, and all the teachers will have more copies of it should you need them. In this question, it's set up a little different. A person uses a lever to move a box 2 meters with an effort force of 10 newtons, and it takes 5 seconds. We can assume that the machine they are using is 80% efficient. Based on the diagram, please solve the unknowns. So we need to find out our load on the resistance arm, our IMA, our AMA, the mass of the load, the work that was done, and the power in watts. Okay, well, let's go for the simple one first, and that is always IMA. So IMA is equal to distance effort divided by distance resistance. So it's the same question, guys. 3 meters on the bottom. IMA is going to equal a factor of 5. The meters cancel. You wind up with 5 over 1, which is 5. So IMA in this case is 5. AMA is an unknown, but we do know the percent efficient. So if we use our formula, percent efficient is equal to AMA divided by IMA times 100, and plug in our values. That means that we have 80% is equal to AMA over 5 times 100. I want to get rid of the 100 and the percent, so I do the opposite, and I wind up with 0.8 is equal to AMA over 5. You simply convert the percent back to a number. Now I need to get AMA over to the left side, and we're dividing AMA by 5. If I need to move AMA to the left side, I have to do the opposite, which is now multiply. So if I go AMA on the left is equal to 0.8, not divided by, but times 5, and that gives us a factor of 4, which is the same as our last question. AMA is 4. Okay, great. Fantastic. We found all that. But what we don't know is now our load on the resistance arm. So in order to find that, we're going to have to use some more of our formulas as follows. If we look at our formula for force, or pardon me, our formula for AMA, so now we're going to find our force output. Let me just change colors quickly here. So this was our mechanical advantage, so I'll just box it off. But we're still kind of dealing with the mechanical advantage formula here. So I might just do it beside it. Another way to find the AMA, or actual mechanical advantage, is by dividing the, and you have this in your formula, your force out by your force in. So if AMA is equal to force out divided by force in, then guess what? If we look at our triangle, like AMA, if I need to find my force out, I have to multiply my force effort by my AMA. This is multiply, and this is divide. So we don't know our force resistance, but we do know our force input and our AMA, so now we're multiplying. So in this case, force out then is going to equal AMA times force effort, or in. So that's going to be 4 times 10 newtons, which is equal to 40 newtons. Okay? So our load on the machine is 40 newtons. Well, that's great. Now they're asking us, what's the mass of the load, how much work was done, and how much power was used in watts? Well, we're already working in newtons, so let's figure out the mass before we go much further. Or no, pardon me, let's figure out the work before we go much further. We'll do the mass last. So let's do the work. So let's go over here. And we'll do the work calculation. So we already know that what the distance is, and we know the load in newtons is 40 newtons. So work is equal to force times distance. So in this case, that's going to be 40 newtons times 2 meters, which is going to be 80 newton meters or joules. Okay? So we're doing 80 newton meters of work. Now it's asking us, and you guys have that right here in your triangle, by the way, work is equal to force times distance. Now it wants to know the power in watts. Well, power is work divided by time. So now the power is equal to work divided by time. So in this case, it's going to be 80 joules divided by 5 seconds. 16 watts of power was used. Okay, great. The last part of this question is asking for mass. So that goes back to our work, power, gravity problems that we're doing. And when you look at the weight and gravity chart here, weight is always in newtons, mass is in kilograms, and gravity is in newtons per kilogram. So if I need to find mass, I have to take my weight in newtons, which is the same as an output or an input force in newtons. Anything in newtons is a force or a weight, and divide it by my gravity. So mass then is going to equal weight in newtons, so 40 newtons, which is weight, divided by my force of gravity, which is 9.8 newtons per kilogram. Okay, so mass then is equal to 40 newtons divided by 9.8 newtons per kilogram. The newtons cancel. Mass is going to be 40 divided by 9.8, 4.08 kilograms, because the newtons cancel. On Earth. Okay, guys, that's how we come up with the solutions for these problems. It will be on your final assessment. So just so you guys know, I'll put that in the screen so it's easy to see. Hopefully it's easy to see. Should be. These are the kind of things we're going to ask you just to make sure you understand how all of this works. And we're going to go through it in class a little bit more as a review. Thanks, everybody.